4 now, and today we're going to start taking a look at the AP exam. We're going to start reviewing for the AP. So we're going to start with the 2016. Here we are at the 2016 AP exam. And the first question, if you hopefully have already read it, talks about water being pumped into a tank given by this rate. Now be careful, this is going, of course, in the tank right there, given by this rate. So maybe remember, because this is a rate, chances are we're going to have to integrate. For the first 8 hours. Then they tell us water is being removed from the tank given by RT. And they give us the table here. That's the water going out. And they give us the table for that. They tell us R is a differential and decreasing on the first 8 hours. And selected value of RT is shown below. At time t equals 0, there are 50,000 liters of water. So chances are what they're telling me right here, this is most likely going to be an FTC problem where we're going to have to solve for an initial value or a value at some point. So the first question, estimate R prime of 2. Well, R prime of 2 is the derivative of R, not W, so be very careful. And because it's a table, we are going to use our average rate of change. So this is an AROC problem right here. And of course, to get R prime of 2, this is an approximation, so I'm going to do my little squigglies. And I pick where 2 is. Well, here's 2. It's between 1 and 3. So it's going to be R of 3 minus R of 1 over 3 minus 1. Now, be very careful. Notice you want to show this on the AP. You want to get full credit for that. And if we type all this in our calculator, on top you get 950 minus 1,190 over 2. And I went ahead and typed this in my calculator. We get negative 120 liters per minute. Now be careful of the units, indicate units of measure. This is already a rate, so this would be like an acceleration. So that's going to be minutes squared right there. And there's our answer for this one. There's the answer for part A. Now this is worth 2 points. So let's talk about where those points come from on the AP. You're going to get 1 point for your answer and 1 point for the correct units. But you need this. The AP will not give you credit if you don't have that. So make sure you have all that stuff on the AP exam, okay? All right. That's question A, part A. Let's go to question part B. And this is where we get into Riemann. Okay. Use a left Riemann sum of 4 subintervals. Now we see Riemann. What did Riemann love most of all of anything? That's right. Riemann loved rectangles. So anytime we see the word Riemann, we think rectangles. Okay? And they tell us 4 rectangles here, indicated by the table that they gave us for part A. So again, by our table here. The total amount of water removed from the tank during the 8 hours. Is this an overestimate or an underestimate? We'll get to that in a second. Give the reason for your answer. All right, so they wanted a Riemann sum. So set up an integral. Riemann sum, find areas. So we are looking at an integral from 0 to 8 of R of t dt. And this is an area problem, so we have to calculate this problem right here. To do that, we can use rectangles, Riemann rectangles. And he says 4 subintervals, so 0 to 2. That would be my width of each rectangle, 4, 6, 8. And he's saying use a left Riemann sum. So what number is on the left between 0 and 2? That's right, 0 is on the left, and it has a height of 1,340. Question between 2 and 4? Oh, this is terrible. I messed up here. Sorry, they're not using 1, 2, 4, and 6, did they? Oh, they tricked me. Look, they use 1, 3, 6, 8, 4 hours. So this should be 1. This should be a 3, and that should be a 6 and 8. There we go. Remember, we can't. The rectangles don't always have to be the same lengths. So between 1 and 3, 1 is on the left, so that's going to have a height of 1,190. Between 3 and 6, we pick the 3 because it's on the left side, 950. And between 6 and 8, we're going to use the 740. And so to get our area, it's going to be approximately, because remember we're looking at an approximation. The first rectangle is 1 by 1340 plus the second one is going to be 2 wide times 1190. The next one is 3 wide, 3 times 950. And the last one is 2 wide, 2 times 740. Now, if you type all of that in your calculator, you're going to get 8,050. Now, let's take a look at the units. R of T is already in liters per hour. DT is already in hours. So my units is going to be liters. And there's our answer for part B. Now, the second part says, is it an overestimate or an underestimate? Well, if we did a left Riemann sum, this is a left Riemann sum, and we're going down. So, of course, this is going to be an overestimate. This is from a long time ago. It's an overestimate, and that is because this is a decreasing function and a left Riemann sum. And that's why it's an overestimate. Take a look back at the notes from a long time ago to get that. All right, so let's take a look at where you get your points on this one. Ready? You get 1 point for all of this setup right here. All of this setup right here. That is worth 1 point. Okay? You get 1 point for the actual estimate itself, but you have to have your reason. I would include that. Always include your rectangles. The AP may not say, hey, you need your rectangles, but you need them. And you get 1 point for knowing it's an overestimate. And by now, you all should have got all of these points right here. These should be pretty easy for you. All right. Now for part C, part C says, okay, use your answer for part B to find the estimate for the total amount of water to the tank at the end of 8 hours. So they want to find, basically, F of 8, how much water is in the tank. And this is our FTC problem. So we're going to set up our fundamental theorem of calculus. So we know that R of T, whoops, sorry. So, excuse me. So we want to know how much water. So to get the amount of water, don't forget, we have to take, well, how much water is gained in the tank and how much water is taken away. So we need the amount of water. So we need the amount of water in minus the amount of water out. Okay, so let's go ahead and set that up right now. Well, to get the amount of water that is in the tank, that goes in the tank, remember, if we go back to the other page, the amount of water going in the tank is modeled by W of T. So this is going to be the integral of W of T dt from 0 to 8 minus the amount of water that goes out. Well, that's what we found in part B. We answered how much water was removed, and we know that that is 8,050 liters. That's from part B. And this is going to equal the amount of water at 8 hours minus the amount of water at 0 hours. This is our FTC step. Well, we're looking for the amount at 8. We know how much water was at the beginning because they tell us at t equals 0, there were 50,000 liters of water. So I know that f of 8, if I want to solve this, is going to equal the integral 0 to 8 w of t dt minus the 8050 plus f of 0, which is at 50,000. And what you wind up with, if you type all of this in your calculator, you just type that in your calculator, what you wind up with is 49,786 liters. And that would be our answer right there. So how would they score this one? you would get 1 point for your fundamental theorem, and you get 1 point for your answer with the units. Not really hard to do. Okay? All right. So let's go ahead real quickly and then go on to part D here. Now, if I'm going too fast, slow it down, pause it if you need to, okay? Whatever you need to do, okay? All right, so let's go ahead and do part C and part D. Now, part D is a tough one. This is one that I haven't seen in the AP too much, but it's a really cool question. It says, is there a time between the first 8 hours in which the rate of water being pumped into the tank is equal to the same rate as being removed? In other words, they're saying, is there a time when the amount of water going in, which we said it was WT, equals the amount of water going out, which is R of T? Explain why or why not. So, first thing I'm going to do is I'm going to set this up. W of T minus R of T. And if they're equal to each other, we know that has to equal 0. In other words, what did I just do? I just kind of solved that. And the AP is going to give you 1 point for this, although they'll give you the point if you got this as well. Okay, they'll give you the point. Now, if you got that far, you're doing pretty darn good on this question. So we want to know, is there a time where they'd be the same? So I can use the intermediate value theorem. I can take the values at t equals 0 and the values at t equals 8 and find out what they are. So if I can find w of 0 minus r of 0, w of 8 minus r of 8. And I can calculate those. Well, if you type those in your calculator, what you wind up with is that t equals 0. This is a positive number. If you type in t equals 8 into the functions, you're going to get a negative number. So what does that tell us? At some point, the value must equal 0. And if the value equals 0, if Wt minus Rt equals 0, then Wt must equal Rt at some point. Okay? So we can say the function is continuous, right? We got to say that. So because W of t minus R of t is continuous, and W of 0 minus R of 0 is greater than 0, and W of 8 minus R of 8 is less than 0, the IVT, and you got to say it, the IVT guarantees that at some point W of t minus R of t has to equal 0. And it's only worth 1 point. It's not worth that much. It's not worth that much. So if you get stuck up on it, don't worry about it too much. But it's worth a point. But if you want to get that perfect on this question, which you should be able to do, that's what you can do there. Okay. All right. So we're going to go ahead and end question number 1 here. Okay. We're going to go ahead and end that. And we're going to part 2 for the next one. Okay. Question number 2 for the next one. I'll see you there.